All right, today we're going to sit down and properly understand one of the most confusing Python concepts, decorators. If you've ever seen someone write the @ symbol above a function, something like this, and you thought, wait, what is this doing? Then this video is going to make everything finally make sense. So let's start from scratch. So the first thing we will do is create a simple Python function. So I'm going to define a function called processData using the def keyword. And inside this function, we will simply print a message that says processing some data. That's it, nothing more. Then right below that, we will create another function, and we'll call this one download file. And inside this one, we will just print the message downloading file. So right now we have two functions, one that simulates processing and one that simulates downloading. And below these, we will simply call both functions one after another. So first we will call processData, and then we will call download file. And if we run the program now, Python simply prints those two messages, and that's it. Now imagine that in a big application, before every single function runs, we want something extra to happen. Maybe we want to print a line that says starting function before it begins, and then after each function finishes, print something like finished function. Now, technically, we could go inside every function manually and add prints at the beginning and prints at the end, but that would make our code messy and repetitive. And if we ever needed to update that message, we'd have to update it inside every function, which is not clean and not reusable. This is exactly the problem decorators solve. So now we're going to create a new function, and this is going to be our decorator. So I will write a function called decorator, and this function is going to accept another function as a parameter. That parameter will represent whichever function is being decorated. And inside the decorator, we are going to define another function, and we'll call this inner function wrapper. Think of a wrapper like a protective shell. It wraps around the original function. So inside the wrapper function, we will first print a starting message, something like starting, followed by the name of the function that is about to run. Then inside the wrapper, we will actually call the original function that was passed in. And finally, at the end of the wrapper, we will print a finishing message, like finished, along with the function name. Once we finish writing the wrapper, the decorator's job is to return this wrapper function. Not run it, just return it, because Python will be the one calling it later. Now, how do we actually apply this decorator to our functions? Very simple. We scroll up to our processData function, and directly above it, we write the @ symbol followed by the decorator name. So we will write @demoDecorator above processData, and we will do the exact same thing above download file. So whenever Python sees the little @ symbol, it knows there's a function called demoDecorator defined somewhere. So Python will then pass our function as a parameter to our decorator. This means that when this function will get executed, they are actually passed into this decorator function and executed through the wrapper, which means when we run the program now, instead of only seeing processing some data, we will first see a line that says starting processData, then the actual processData text, and then a line that says finished processData. And the same exact flow happens automatically for download file, without changing a single line inside the original function. And this is where decorators click and finally make sense. We did not change the original functions. We simply added behavior around them. And now we can reuse this decorator on hundreds of functions if we want. So that's how decorators actually work. Just a function that takes another function, adds extra behavior, and gives back a new function.